Good morning or afternoon or evening, depending on when you are watching this presentation. I'm Ben Brosgol from AdaCore, and in my talk today, I'll try to resolve what seems to be a paradox. How can a company sustain a profitable business when it seems that they're giving away the crown jewels? AdaCore is a software company specializing in development tools for the Ada programming language. Our products are open source, or more specifically, freely licensed open source software, or FLOSS, so our customers receive the complete source code along with the binaries. That may seem like a risky strategy. What's to prevent a customer from co-opting the source code and generating the tools themselves so that they don't need to pay for the software, or worse, maybe even going into competition with us? Well, that scenario sounds frightening, but it hasn't occurred. We've been in business for more than 25 years and have shown steady growth and profit during that time. In this talk, I'll explain how. And if you'd like to learn more about this topic, please read the original paper, which appeared in IEEE Software at the end of 2019. First, a few preliminaries on why the software business is unique. Some of this may seem obvious, but please bear with me. Unlike the situation in industries that produce material goods, the products of a software company are easy to copy. Now, there are technical solutions to this problem. In the early days of the PC era, I worked for a company that required a hardware dongle to be plugged into the parallel port in order to activate the product. But these are unwieldy and a major hassle for customers who simply want to use the product legally. And also, unlike the products in material industries, software does not wear out. So the planned obsolescence that encourages a consumer to purchase a new car after so many miles or years is not a viable strategy for a software producer. The company needs to provide upgrades and enhancements, or else the customer will simply continue to use the existing product. Where will the funding come from for those upgrades? Is the pricing model a large upfront payment for the software and then runtime license fees over the long term, or something else? Having good answers to these questions is key to running a successful business. And an important factor is the choice of licensing for the software products, and in particular, the permissions or restrictions on source code availability and usage. Somewhat simplified, there are two basic approaches. With a proprietary license, like what you'll see for commercial desktop applications, the source code is either not supplied at all, or if it is, severe restrictions limit its usage and prohibit its further distribution. And of course, reverse engineering the binaries to generate the source code is forbidden. With a non-proprietary license, the term I'll use is FLOSS for freely licensed open source software, the source code is included with the product and can be copied and adapted by the user. And there are other aspects that I'll talk about later. AdaCore has adopted a FLOSS model for all of its products. I'll explain why and show how this has helped rather than hindered the company's business. First, some history, since the FLOSS decision dates back to the project that gave the company its start. In the early 1990s, the original Ada programming language was undergoing a major upgrade under the sponsorship of the U.S. government. The sponsors saw the benefit of having Ada taught and used in academia, and they wanted to make sure that a quality compiler would be available for free to colleges and universities when the revised language came out. So they funded a team at New York University to write a compiler that would be free, in the sense of free beer, and available on the platforms common in the academic community. The project leaders needed to find an effective solution from both a technical and a licensing perspective, and they settled on the GNU technology from the Free Software Foundation. The FSF would supply the GCC and GDB software, compiler backends and debugging support, and related tools such as the binutils, and the NYU team would produce the Ada-specific components, the compiler front end, and the necessary runtime libraries for services such as dynamic allocation, concurrency, and exception handling. The project was successful, and the outcome was a somewhat bare-bones compilation system for the then new language Ada 95. It was given the whimsical name GNAT, which originally stood for GNU NYU Ada Translator. The expansion has long since been abandoned, but the acronym has persisted. Since it incorporated GCC components, the GNAT software was covered by the GNU General Purpose License, or GPL. I'll be covering this in more detail later, but here I'll mention several important consequences. The binaries for the Ada compilation system included the GNAT source code, which users had permission to copy or adapt. If a GNAT user built and distributed software that included a GNAT component, for example, a static analysis tool that incorporated the GNAT compiler's front end, then they would need to include their own source code and either the GNAT code itself or a pointer to wherever the code was retrieved from. If their software contained a modified version of any GNAT source files, then the distribution would need to include the modified files. In either case, the GNAT user's source code would need to be made available under the same GPL terms as GNAT itself. On the other hand, if the GNAT user never distributed their binary, then they would have no obligation to distribute their source code or otherwise make it available. This last aspect is important. A GPL license does not require source distribution if the software is only used internally. Since GNAT was intended for academic usage, the GPL license made sense. There are some additional licensing issues concerning GNAT runtime libraries if the user distributes a binary built by the GNAT compiler, but I'll get to those later. Although it was targeted for academia, the GNAT compiler incorporated professional-grade compiler technology, and the project leaders recognized the commercial potential if they turned it into a viable product, for example by focusing on performance, adding some tools and documentation, and porting it to new platforms. There was an existing customer base that looked promising, users of the original Ada language, largely from the military and aerospace communities, and other developers of high-assurance software who were using C or other languages that lacked the compile time and runtime checks that Ada offered. And so in 1994, the GNAT project leaders from NYU, Robert Dewar, Ed Schoenberg, and Richard Kenner, founded AdaCore in the US. 2 years later, a sister company was founded in France by fellow GNAT team members Cyril Komar and Franco Gasparoni. The initial product was the GNAT Ada 95 compilation toolchain and debugger. Productization and further development were funded by contracts from Silicon Graphics and Digital Equipment Corporation to port GNAT to their respective platforms, IREX for SGI and Alpha VMS for DEC. Now, these were one-off contracts, and a different and more predictable source of revenue would be needed to support continued growth and technology enhancements. One approach that's common for proprietary software is to charge a large price initially and then additional fees for runtime licenses or support. However, this typically results in an uneven and unpredictable revenue stream, and the GPL terms as well as other considerations ruled out charging for runtime licenses. Instead, AdaCore chose a business model based on an annual subscription at a price reflecting the value that the company added to its FLOSS software, an expert level of support coupled with assurance about the software's licensing status. The subscription model has the benefit of revenue predictability and also incentivizes the company to provide improvements that encourage customers to renew. There are no runtime license fees. From the outset, AdaCore envisioned two user communities for GNAT: individuals or academic institutions adopting Ada for free software development or teaching, and companies or other organizations using Ada to implement professional-grade software for commercial or government-sponsored projects. The version of the GNAT technology for free software developers in academia has helped Ada gain traction in those communities and is currently referred to as the Community Edition. It consists of a no-cost downloadable executable, and source code of course, for the compiler and accompanying tools and libraries. Its GPL licensing is appropriate for academic usage and for free software development. The professional version, known as GNAT Pro, shares a common code base with the Community Edition, but has several important differences. Customers gain access to the toolset through an annual paid subscription with a license that accommodates software developers who do not want or are not allowed to distribute their source code along with the executable. It comes with product support that includes guaranteed rapid response to questions and defect reports with access to wavefronts, specially generated interim releases, if needed to correct critical problems. Support is provided by the product developers themselves. GNAT Pro undergoes a more extensive QA regimen with nightly regression testing consisting of millions of lines of test cases on many platforms, and some specialized tools are only available with GNAT Pro. Both versions have annual major releases, so all users can keep up to date with product enhancements. For GNAT Pro, that also serves as an incentive for customers to renew their subscriptions. A close relationship with the FSF helps here, since the GNAT technology can take advantage of GCC improvements such as new code generators and back-end optimizations. Now recall that the GNAT technology includes two kinds of software. On the one hand, a compiler and other tools that are invoked by the user, but which are not part of the executable that the user is producing. And on the other hand, runtime support libraries that are linked with the user's object modules produced by the GNAT compiler and which do form part of the final executable. For GNAT Pro, different licensing is needed for the two cases. The compiler and tools are covered by the GNU General Purpose License, more specifically GPL version 3. As mentioned earlier, if a user builds the compiler or tool source code, either modified or unchanged, and then distributes a binary version of the result, then they have to also make the resulting source code available under the same GPL version 3 terms. This scenario comes up in practice, for example, Red Hat's distribution of the GNAT Ada toolset from the FSF repository, and helps ensure that FLOSS software stays both freely licensed and open. The runtime library situation, however, is different. Runtime libraries are linked with object modules from user code, and if the libraries were covered by a GPL license, then a user distributing an executable would also need to distribute the source code for their own components. But GNAT Pro is intended for users who may need to develop software that can only be distributed in binary form, for example, for proprietary or classified systems. The runtime libraries for GNAT Pro, like those for GCC libraries, therefore carry an exception to the GPL. You can freely distribute your programs built with the GNAT Pro compiler, including any required library runtime units, using any licensing terms of your choosing. This does not apply to the GNAT Community Edition. Those runtime libraries are covered by the GPL without any special exception. Since the Community Edition is intended for free software developers and academic users, the GPL licensing is appropriate. Let's go back to the issue of FLOSS licensing and look at both some non-reasons and some reasons for selecting it. Eric Raymond once said, "Given enough eyes, all bugs are shallow," which is sometimes interpreted as implying that software in open source repositories is more secure than their proprietary cousins. But the opposite claim has also been made, sometimes referred to as security through obscurity. In other words, if the source is hidden, then bad actors will have a more difficult time to find weaknesses. In fact, high-profile vulnerabilities have occurred in both FLOSS and proprietary software, and there's no intrinsic security benefit in either approach. An effective software lifecycle infrastructure, verification and static analysis tools, configuration management, QA processes, and so on, is a much more important contributor to security and other quality criteria. AdaCore chose a FLOSS approach for other reasons. The company's founders shared the FLOSS philosophy that openly available source code can help the software community advance. That's been our experience. For example, one of the breakthroughs in the Ada community was the so-called Ravenscar profile, a subset of the concurrency features with a small footprint that can be used in safety-critical and/or memory-limited systems. The FLOSS licensing for GNAT has allowed researchers to investigate implementation techniques and variations on the Ravenscar features that have advanced the state of the art. A production-quality Ada compiler technology targetable to a variety of processors was a major goal from the outset. The GCC technology offered an effective solution, and this required FLOSS licensing. The company founders felt that making product source code available to customers and contributing components to the FSF were not endangering its business. Compiler construction is a specialized field, the Ada market is a relatively narrow niche, and the expertise needed to package the FLOSS components into a commercial product and then to provide the necessary technical support is high. The risk of the source code being used by potential competitors would be low. An open source license for a software product simply means that the product includes source code. A wide variety of open source licenses are out there with a wide range of accompanying permissions or restrictions. AdaCore chose the GPL for a couple of reasons. First, software licensed under the GPL cannot be made part of proprietary software and will always be freely available. Recall that this applies to the compiler and tools, The runtime libraries are different. And second, software distributed under the GPL version 3 cannot be used in hardware that forbids other software from running on that hardware. The FLOSS community is, of course, not a monolithic entity, and producers and consumers of FLOSS software exhibit a range of traits and behaviors. For example, FLOSS technology may be either intrinsic to the business of the software producer or only an incidental component. Consumers may have little need to be experts in the technology that they are using, or they may be technically savvy. And the FLOSS software might be critical to the success of the consumer's mission, or simply a minor contributor. The characteristics of a particular situation affect the type of business model that is most likely to succeed. In the case of AdaCore, the FSF components are intrinsic to the GNAT technology, and the company therefore needs to have deep in-house expertise in multiple areas, including compiler construction, and GCC in particular, programming language semantics, including Ada, C, and C++, hardware architectures, and operating systems. And indeed, over the years, AdaCore has built up its staff with those requirements in mind. The Ada language in general, and thus AdaCore's products, are aimed at customers developing critical systems on a wide variety of platforms, both native and embedded. GCC has been instrumental here, and since GNAT Pro users have often needed to field software with safety or security requirements, having dependable development tools was essential. Customers are domain specialists, but not necessarily compiler experts. Tracking down a defect that might be a coding error, a hardware problem, an operating system anomaly, or a code generator bug can be tedious and difficult. Rapid and accurate defect detection and correction are needed to keep a project on schedule, and so the support provided with a GNAT Pro subscription has been an attractive incentive. An Ada compiler is not a fungible commodity. It's an essential contributor to the ultimate outcome of a customer's project. And although customers do not contribute FLOSS components directly, their feedback on the GNAT technology has often resulted in product enhancements that AdaCore later contributed to the FSF. AdaCore has had a close relationship with the free software community in several ways. The company periodically pulls new versions of GCC and GDB from the FSF, and in the other direction, it pushes new versions of Ada-specific components. AdaCore has also contributed in other ways, for example by reporting code generator issues and thus improving overall GCC quality. In recent years, GitHub has grown to be a significant repository for FLOSS software, and here AdaCore has also made a number of contributions. So let's go back to the questions that we posed at the beginning. How can a company that uses FLOSS licensing protect its investment and prevent unauthorized uses without inconveniencing customers who use the product legitimately? A specialized product like GNAT Pro, targeted to industries like aerospace that are attentive to licensing terms, is not the kind of software that has a high risk of being pirated. So AdaCore has regarded the benefits of FLOSS as far outweighing the potential downside of unauthorized usage, and the intellectual barriers to entry for a commercial-grade Ada compiler have made it highly unlikely that the GNAT software would be used to seed a competitive product. Further, making the source code available is an advantage rather than a risk, since customer familiarity with the product, especially the runtime libraries, can help. The other question is how to establish and sustain a profitable revenue stream and make sure that there is funding for ongoing development. Here is where the annual subscription model is important. The subscription price reflects the value that AdaCore adds to the FLOSS software, and this is in support that the company offers based on its in-house expertise. Support is provided by the product developers themselves and covers all aspects of the technology, product usage, language semantics, programming style, and so on. The subscription also assures the customer that they have a legitimate license to use the product. If a subscription expires, there are no such guarantees. The subscription model is well tuned to a customer base that develops systems that need to meet requirements for reliability, safety, or security, since expert and timely support is more than a luxury. The subscription model has proved successful over the years. A large majority of the company's revenue comes from subscription renewals, which have funded ongoing product development and enhancements. In a virtuous circle, the annual release of new or enhanced products has then incentivized customers to renew their subscriptions. In summary, the use of FLOSS components and licensing can save development costs and serve as the basis of a profitable business. By using GCC, AdaCore has been able to target the GNAT Pro product to a wide range of processors and operating systems and take advantage of code generator improvements and other FSF technology advances over the years. AdaCore is not unique. Other companies have also successfully adopted a FLOSS-based business model. One example is Red Hat, which has offered products and support services around a variety of technologies, including Linux, the FSF software development toolchain, and enterprise software. FLOSS has brought different kinds of benefits to Red Hat and AdaCore. It's allowed Red Hat to provide a price-competitive alternative to the proprietary operating systems prevalent in the marketplace, most notably Windows, whereas for AdaCore it has supplied a technology resource, GCC, for the company's compiler development. The markets for the company's products are also rather different, with AdaCore's being a smaller and more specialized niche. Notwithstanding these differences, the companies have succeeded with FLOSS through similar subscription-based business models. They make money from FLOSS licensed software by adding value through support and related services, and each company actively coordinates with its FLOSS developer community as both a contributor and a consumer. The use of a FLOSS license like the GPL means that AdaCore's intellectual property is not embodied in the source code of the products that it offers. Instead, the IP really lies in the full complement of processes that the company performs and the resulting assurances. Artifacts like the extensive test suites that are used in QA are part of this IP. They are not freely licensed, and indeed they couldn't be, since they include customer proprietary code. So what are some of the lessons learned from AdaCore's perspective as both a user of and a contributor to free software? The main point is the benefit of the annual subscription model for a customer base that is developing critical software and therefore may need the added assurance that comes with expert and timely support. In effect, the company's support is a dialogue with customers and a relationship that yields product improvements, new tools, bug fixes, and other enhancements. It is more cooperative than the usual one between a software producer and consumer. AdaCore's customers often need to develop large and long-lived systems, and the guarantee of keeping the compilers and tools up to date and in sync with new requirements, as well as new technologies, is a strong incentive for customers to renew. A couple of additional takeaways from AdaCore's experience stem from GNAT's strong dependence on the FSF's compiler technology. First, since AdaCore needs to support the external FLOSS software, GCC and GDB in the case of GNAT, the company needs deep internal expertise on those components. And second, synchronization with the FSF must be carefully coordinated: when to upgrade to a new version of GCC, when to commit a new version of the Ada components, in order to avoid disruptions. AdaCore has traditionally seen a subscription renewal rate of more than 90%, so giving away the source code is not a path to insolvency, but rather a sound and profitable business strategy.